have radioactive substance, initial mass of 144. We've got kind of the equation set up for us down here. Substance follows a continuous exponential decay. So again, PE to the RT. Half-life of 14 days. So that means after 14 days, when T equals 14, there will be half of what we started. So one way we can set up this equation is we know what we started with. This is our initial mass. So it's 144.6 E to some rate times T, which we're going to set it up for 14 days, because in 14 days we know there will be half of this left. So half of 144.6 is 72.3. So that's where that came from. The thing is watch how this is going to really simplify nicely, how we can go about solving this. Now, yeah, you could graph this. Maybe we'll do that second, but the other way, we can divide both sides. So we're trying to isolate this. 144.6, 144.6, because we're trying to find that rate. The thing is that makes this a little hard is the rate is going to be a decimal. So it's very close to the y-axis, but you'll see here. 72.3 divided by 144. Well, we actually just did that. That's going to be 1/2. And if you don't believe me, which maybe you don't, you say, how do you do that so quickly? It's because we did it, right? 72.3 divided by 144.6. It's got to be 1/2, right? Because we divided that by 1/2, 0.5, which is 1/2. Okay. And so that cancels. We have E to the R. And I'll just put the 14 in front because it's a little nicer to look at that way, E to the 14R. And so again, to solve this one, we do the log dance. Log base E is written as ln. Notice the E separates from the 14R. That's the exponent, that's the answer to a logarithm. And this becomes the natural log of 1/2. And then we just divide both sides by 14. Now, if you want to, you could have remembered that, for half-life, you take the natural log of 1/2 and divide it by whatever the days are. So yeah, you could remember that, sure. Maybe. There's a lot to remember, but so this is kind of a formula. R is going to be this, and so that we can come in here and natural log of 1 divided by 2 divided by 14. This is going to give us our rate. So it's decreasing, and that's, because, yeah, if you were doubling, we would increase, but we're decreasing, and they want, let's see, use a formula rating. Oh, use exact expressions. Actually, I don't want to do this. I know it's almost 5%, right? But exact expressions. So this is why I can't just do it by graphing. This is the value of R. Okay, so I'm going to have to actually put that in. Clean this up a little bit. There we go. So we have the 144.6. I can put that in, 144.6. For this exponent up in here, which looks like it's already in parentheses, I'm going to put, I need a fraction. In the top, I need my natural log of 1/2 divided by 2. There we go. And in the denominator, I need 14. That's what they want there. Don't put in this decimal. It won't get marked as correct. There we go. And then now, how much will be present in 8 days? Now that we have this, we plug in 8 for t, and now we can calculate it, and they do want it rounded to the nearest tenth. Okay, so we can come back here. You could use the Alex calculator if you like, but we're going to calculate it as 144.6 E. Oh, wait, yeah. We're just using this formula. E raised to the, I'm going to put a parentheses, And I'm going to put in this exact figure so we can kind of get there, right? Natural log of 1/2 divided by 14. That went off. Times by t, which in this case is 8. That will calculate it all for us. Notice we have more than half left because it would take us 14 days to get down to half, so 97.3. And that's how we do this last one, number 8.